Hi, my name is Joanna Lemley, and I'm a wetland ecologist with the Colorado Natural Heritage Program. The following presentation will cover plot layout options included in the field protocol for lentic, riparian, and wetland systems, the official protocol of the Lentic AIM program. You can follow along in section 4 of the draft protocol, starting on page 31. I will also touch on photo points, which are covered in section 5.2 on page 56. The field protocol for lentic, riparian, and wetland areas is applicable to a wide variety of habitats that occur on an equally wide variety of sizes and dimensions. In addition, monitoring objectives for some targeted sites may focus on smaller zones of interest within a larger site. Plot layout options then balance the need for flexibility with standardization. The protocol includes 4 plot layout options: a spoke layout, a transverse layout, diagonal layout, and a linear layout. All layouts share a few common characteristics: 3 25-meter transects spaced 5 meters apart, transects spaced evenly across the plot, a maximum area of 0.3 hectares or 3,000 square meters. There's no minimum area of a plot, but there is a maximum length of 200 meters. Of these plot layout options, the spoke layout is the standard plot layout and should be used wherever possible. Plot layouts are based on the width of the riparian or wetland site at or near the sample location. Even within the same riparian or wetland site, sample locations in different areas may result in different plot layouts, as shown in this figure. Page 31 of the manual includes a key to plot layouts, here shown in a graphical format. The key provides breakpoints for each layout option. If a site cannot accommodate the spoke layout, which is a 30-meter radius circle, an alternate layout must be used. While the layouts are described as separate options, you can really think of the transverse, diagonal, and linear layouts as existing on a continuum from wider to narrower sites. If the site is greater than 25 meters long, then the transverse layout is used, and the transect should cut across the site perpendicular to the long axis in a transverse or cross-cutting fashion. As the site becomes narrower than 25 meters, the transects will be pitched on an angle and cut across the short axis diagonally. At less than 2 meters in length, the transects are essentially stretched linearly along the long axis. A key concept to understand in plot layouts is the option to shift the monitoring plot. When possible, monitoring plots should be centered on the sample location. However, the plots may be shifted away from the sample location for a variety of reasons, including that the sample location is on the edge of a riparian or wetland area, outside the wetland or riparian area in upland vegetation, in deep water, or on the edge of BLM lands. This is a very important concept, particularly for randomly selected sites. Most randomly selected sites are selected from National Wetland Inventory, or NWI mapping, made by the U.S. Fish and Wildlife Service. This is the only comprehensive wetland mapping data in the United States. Some NWI data are over 30 years old and not very precise. It is not uncommon for the boundaries of an NWI polygon to be slightly off from the actual wetland on the ground. Points drawn from this mapping may be in upland areas, but close to wetland features. If necessary, a monitoring plot can be shifted to the closest applicable riparian or wetland area that is no more than 50 meters from the sample location. This slide shows an example of a plot that was shifted slightly to the west to be more fully within the riparian shrubland. In this example, the sample location was right on the edge of BLM land, and the shift allows the plot to be fully within BLM managed lands. A shifted plot does not need to be centered or even contain the sample location, but the edge of the monitoring plot must be no more than 50 meters from the sample location. In some cases, this may mean that the plot center, which is deeper into the plot than the edge, obviously, could be even further than 50 meters from the sample location. But as long as the edge of the monitoring plot is no more than 50 meters from the sampling location, then the shift is allowed. There are a few additional considerations for shifting a monitoring plot. A plot can be shifted if the shift will allow the plot to be in a wider area, although crews should minimize shifting while establishing the most efficient plot possible. But it is preferable to sample a standard spoke layout rather than a narrow layout if a small shift would allow a full standard layout. In addition, if a site has a fenced exclosure, it is helpful to shift the plot to be either within or outside of the fence so that the conditions within the monitoring plot are consistent. The distance rules for shifting does not apply in the same way to targeted sites. In targeted sites, there is more flexibility to shift a plot away from a sample location if the sample location originally selected does not adequately represent the conditions that are intended for the monitoring. In those cases, it is important to work with your BLM contacts to make sure that the monitoring plot is established in an area of interest. I will now walk through each of the 4 plot layout options. First is the spoke layout, which is intended for riparian and wetland areas large enough to accommodate a 30-meter radius circle, or 60 meters across. The spoke layout encompasses roughly 0.3 hectares or 3,000 meters squared. This layout includes 3 25-meter transects that radiate from the plot center with a 5-meter gap. Transects are spaced 120 degrees apart, typically at 0 degrees, 120 degrees, and 240 degrees. If there is non-target habitat within the plot, the angle of the transects can be adjusted to avoid them. The transverse layout is intended for riparian or wetland areas between 25 and 60 meters in width. It encompasses up to 0.3 hectares, but can be smaller depending on the dimensions. The transverse layout includes 3 25-meter transects established perpendicular to the long axis. Transects should be spaced equally or equidistant between the center and the far edges of the plot. The transects may or may not be parallel depending on the curve of the system. This illustration shows them being parallel, but if the system is slightly curved, the transect should stretch across and perpendicular to the long axis at the point where they are established. If the average width of the plot is greater than 25 meters, then the transect should be staggered along the short axis so that the center transect, transect 2, is centered in the middle of the width, but transects 1 and transects 3 start on opposite sides of the monitoring plot. The size and dimension of a transverse layout are determined by the width of the riparian or wetland site. Table 5, which is on page 40, provides guidance on plot dimensions and transect spacing. Be sure to read the footnotes so that you understand this table. The footnotes explain that the maximum plot length is the length needed to achieve 0.3 hectares or 3,000 meters squared. So it's that area, 3,000 meters, divided by the width, whereas the minimum plot length is capped by the average width. The minimum plot length cannot be shorter than the width because the length is measured on the long axis and the width is measured on the short axis. Any length less than the maximum plot length will result in a monitoring plot smaller than 0.3 hectares, but that is perfectly fine. There is no minimum size to a plot. The diagonal layout is intended for riparian and wetland areas between 2 and 25 meters in width. It encompasses up to 0.3 hectares, but can be much smaller. The maximum length for a diagonal and a linear layout is 200 meters, and that is to prevent plots that are too long to adequately walk back and forth to monitor within one monitoring session. The diagonal layout includes 3 25-meter transects that are stretched as far across the short axis as possible with the lowest angle possible. The transects are spaced equidistant or equally again between the center and the far edges. Again, the transects may or may not be parallel depending on whether or not the system curves. In contrast to the transverse layout, distances between the transects in a diagonal layout can be measured either from the midpoints, the center of the transects, or from one end of a transect to the beginning of another. As sites become more narrow and longer, more stretched out, it is often more efficient to lay out one transect and then measure the gap and then begin the next transect, rather than trying to measure from the midpoints of the transects. I will show an illustration of this process in an upcoming slide. Like the transverse layout, size and dimensions are determined by the width. Table 6, which is on page 43, provides guidance on plot dimension and transect spacing. This table provides transect spacing based on both the distance between the midpoints, if the transects are overlapping, and distance from the end of one transect to another. The fourth layout is the linear layout, and this is intended for very narrow riparian and wetland areas that are less than 2 meters in width. The minimum length is 75 meters to include all 3 25-meter transects. The transects may bend with the system as shown in this photograph. And I'm sorry, the maximum length, I should say, is 200 meters, just like the diagonal layout, to avoid plots that are just simply too long to measure in one monitoring period. The linear layout can be used in very narrow drainages, such as the one shown in this photograph, along the shore of a lake or pond with just a narrow rim of wetland vegetation, or in a narrow zone of interest within a larger riparian or wetland area. And then lastly, the protocol contains a mixed layout that is intended for riparian and wetland areas where the width is not consistent. This layout essentially combines elements from multiple layouts previously discussed. In order to lay out a mixed layout, draw the boundary of the monitoring plot, which is often the boundary of the wetland or riparian area or zone of interest, and then attempt to space the transects as evenly as possible throughout the plot. But do not worry, do not spend too much time overthinking the layout. Monitoring plots in these sites are difficult to lay out. Use your best judgment and document your process. Now I'd like to present some plot layout examples. For all plot layouts, the process follows the same 6 steps. Step 1 is to locate and evaluate the sample location. In this case, the sample location was in the upland, 10 meters east of target habitat of a wetland or riparian area. Step 2, if necessary, is to shift the plot center away from the sample location. In this case, it is shifted into the spring-fed shrubby wetland. Next, determine dimensions of the plot by measuring the average width. In this case, the wetland site's average width was 65 meters, so it does fit a spoke layout. Step 4 is to determine spacing of the transects. In this case, with a spoke layout, we know that the transect should be radiating from the center at 0, 120, and 240 degrees. Again, the spokes can be rotated to avoid non-target habitat in a plot if necessary. Third is to establish a transect, which we will go over in the field. And then 6 is to mark the location of the transects on a map and a site drawing. Here's another example. Step 1, locate and evaluate the sample location. In this case, is within qualifying habitat. If necessary, shift the plot center away from the sample location. In this case, not necessary. Step 3, determine the dimensions of the plot. In this case, the average width of the wetland and riparian area was 25 meters. This calls for a transverse layout. Then determine the plot length, which we calculate by considering the maximum plot area of 3,000 meters squares, dividing that by the plot width of 25 meters, which gives us 120 meters in length. Now that's the maximum plot length that we might hope to find. And in this case, the site accommodates the maximum plot length of 120 meters. It is helpful at this point to draw a boundary, a rough approximate sketch of the boundary on a map so that you can conceptualize in your head where the monitoring plot is located. This helps when laying out the transects. Step 4 is determine the spacing of the transects. The total plot length is 120 meters. Because it is a transverse layout, we can divide that by 4 and space the transects 30 meters apart. The one in the very center of the plot, and transect 2 is in the very center of the plot. Transects 1 and 3, are 30 meters away and also 30 meters from the end of the plot. Then establish the transects, pulling a tape out through the vegetation in the most straight line as possible, and mark the location of the transects on a map. Here's another example of a plot layout in a diagonal layout. Step 1 is to locate and evaluate the sample location. In this case, the sample location was in upland, just 4 meters southeast of qualifying habitat. If necessary, step 2, if necessary, shift the plot center away from the sample location. In this case, the plot center was shifted slightly into the vegetated drainage way. Then determine the dimensions of the plot. Here, the average width of the system was only 4 meters wide. This is a very narrow diagonal layout. The plot length is determined by taking that maximum area of 3,000 meters squared, dividing it by the plot length of 4 meters. Now that would result in a plot that was 750 meters long, which is too long for us to monitor. So this is a case where the plot length is capped at 200 meters. Step 4 is to determine spacing of the transects. We take the total plot length, and in this case, because the transects are stretched out in a narrow and long layout, we can subtract the total transect length of 75 meters from the total plot length, and then divide that resulting length by 4 so that we have equal distance between the center and the 2 other transects, and also between the edges of the monitoring plot. So that results in a spacing of 31.25 meters between the end of one transect and the start of the next. Once that is conceptually figured out, then you establish the transects on the ground by stretching out your transect tape and marking the transects, the location of the transects on a map. The Survey 123 form for plot characterization on your iPads will guide you through the decision-making plot process for plot layouts. This is a screen capture of the Survey 123 form, and the first question it asks is for the average width of the wetland or riparian area. Here's an example where the average width is 45 meters. The iPad will guide you and suggest a transverse layout. The next step is to measure the length of the wetland or riparian area that you are about to sample. The maximum plot length for a transverse layout with a 45-meter width is 65 meters. But in this case, I've measured my wetland or riparian area as only 50 meters. So then the iPad will guide you to a potential transect spacing of 12.5 meters between the midpoints. In this example, the average width of our wetland or riparian area is 15 meters. The iPad suggests a diagonal layout. It also suggests that the maximum plot length is 200 meters because that is our cap. But it asks what is the actual length of the wetland or riparian area. And in this case, again, my wetland or riparian area was 50 meters. So again, the transect spacing would be 12.5 meters from the midpoints of the transects, but you could look to the table to find a spacing from the end of one transect to another. I'll also say a few things about transect photos now, because we take photos at both the start and the end of each transect while laying out transects. These photos should include a photo board to show the site ID, the transect number, and the date. Photo polls should be included when possible to take the photo at a consistent height. Some of these photos were taken before we established the rule about the photo pole. Here are some characteristics of a good transect photo. The sky is included for scale and to provide reference for revisits. The transect tape is visible, and the beginning of the transect is clearly marked with a pin flag. The photo board is held by a person with only the hand or arm showing, not the full body of the person, but it is clearly identified, clearly visible, and clearly identifies the site. In addition to transect photos, it is helpful to take an overview photo that provides context of the site in the landscape. Look for a vantage point that is higher than the plot if possible. And if the transects are visible, that is also very useful. In addition, we take a number of other photographs of features of interest, including anything notable you may see while sampling. It is helpful to include an object for scale, such as a clipboard, a tape measure, a shovel, or a person. And all these photographs will be uploaded into the iPad. The iPad also contains a list of other required photographs, such as a soil pit or hydrologic features that we will discuss in other presentations. That concludes this presentation on plot layout and photo points. Thank you very much.